Good evening, everyone. Today's my talk is about Oozie and Zero Downtime. My name is Purushottam Shah. This talk is also supposed to be presented by my friend Royata, but he can't make it, so I'll be also presenting on behalf of him. We both works, we, we both work at Yahoo, and we both are Oozie committed. The agenda of this talk will be something like that. Initially, we'll start with introduction. We'll talk of scale at Yahoo. We'll see some of the life use case, and then we'll discuss why zero downtime matters. Then we'll talk of some of the architectural overview and some of the technical challenges, mainly in terms of security, log streaming, HCAT integration in HA. Then we'll share our experience and some of the future work. Let's start with very basic. Why do we need Oozie? Doing something on the grid often requires multiple steps. You can't do it in one MapReduce job or one single Hadoop job. Running a complex pipeline required multiple steps. You need to launch MapReduce job, you need to launch peak job, you need to launch streaming job. You have to do some DFS operation like making directory, changing permission, removing directory. And besides running this all steps in a sequential or parallel way, you also want to do some processing periodically. You want to run some workflow on some set of data at every time. Oozie does that. Oozie, where you can create a workflow, it does multiple things in a sequence way or in a parallel way. It's all depending on the configuration. It's also had a coordinator where it can run periodically and do some processing. This is very basic. Oozie does more than that. Let's move on to a scale at Yahoo. So currently, Oozie is deployed in all of the Hadoop cluster at Yahoo, and we have one instance per cluster. If you see in terms of product, we have around 75 product running on the cluster, and more than 200K projects. We have around 255 monthly users using Hadoop. In terms of Hadoop statistics, you see, we submit around 29 millions of workflow monthly. And out of that, 72% are submitted from Oozie. If you look at the Oozie statistic, we submit more than 100K job daily. And each of jobs has, on average, 4 actions. We also have a very extreme use case where one of the user, they submit 100 to 200 workflow per minute. In terms of coordinator, we have around 1,700 coordinator running daily. And the frequency of coordinator are 5 minutes, 10 minutes, hourly, daily, weekly, monthly. And mostly around 25% are 5-minute jobs. We also have around 60 bundle running daily. If you look at the Hadoop job distribution, you'll see that 47% job which get executed at Yahoo are peak job. 36% are Oozie launcher job. We have 7% Java MR job, 5% are Hype job, 4% GDM, and others 1% falls in streaming, DCP, Spark. If we categorize all Yahoo businesses and then see who all uses Oozie. So in advertisement category, ad exchange, ad latency, search advertisement team, they all use Oozie to do their data processing. In terms of content agility, content optimization, content personalization, Flickr team, they use Oozie. Targeting team, they use Oozie for audience targeting, behavioral targeting, partner targeting, retargeting, web targeting. They use Oozie. Mail team, they use Oozie for anti-spam detection, content analysis, retargeting. In data analysis category, research folks use Oozie a lot. Oozie is used for dashboard and reporting, used for forecasting. In data management, the data pipeline team also uses Oozie. And we'll see one of the live example of data pipeline. This is one of the live example of uh, within Yahoo how they use Oozie. This is a fairly complex use case, but this is not the most complex use case, but this is one of the complex use case. So if you see those 15-minute, hourly, and 5 minutes, those are the input data they received. Those are events generated from multiple sources. Those event content, click information, view information. And in the rectangular box, those are the bundle. In Oozie, you can combine multiple coordinator in one bundle. If we have a data dependency, like sometimes one coordinator input data is dependent on the coordinator of other output. So we can combine them. If you want to rerun, you can run the whole bundle. So what happens is that it can process the whole dependency part. So, so what they do is that they receive input from different source at the frequency of 15 minutes, hourly, and the 5 minutes. And the core logic is within the core bundle. Core bundle does most of the core logic. They start with the transformation. The raw data which they receive, it's normally in Avro format, and they convert into protobuf. After that, they also do normalization. So what they do is that if the event is missing some of the advertiser information, they look at the DB and update that. They also do conversion attributes, like if somebody has bought diaper, they also do and analyze what made him to buy the diaper. And the core bundle also produce a matrix which is used by RebMom bundle and AWD bundle for monitoring and reporting purpose. The output of core bundle on hourly basis goes to RebMom bundle, which is basically for monitoring and alerting. Then the hourly data also goes to AWD bundle, which is mainly used for reporting. So output of AWD bundle is displayed in UI where people can see the report. The 5-minute output of core bundle goes to invoice bundle, which generates an invoice and pass it to respective team. MDQ bundle, so we also, inside they store their all advertiser, publisher, every information in MySQL database, which is the source of truth. So whatever comes at the input event, we validate against MySQL, and if anything is mismatching, we update that. So MDQ bundle doesn't do anything. It just reads data from MySQL and put into SDFS so that core bundle can use it. We also have an archive bundle, which doesn't do much. Just takes the input, archives it, and put into SDFS, so that if later they want to refer that, they can do that. And if something is wrong, what they can do is that they can unarchive that and then run that particular data set. So I'm switching context here and going internal to Oozie. We talked about coordinator. We talked that it runs at every frequency. So when coordinator runs at every frequency, it creates a cord actions, which checks for input data set. So this graph shows on daily basis how many coordinator actions are created over time. So if you see at 00 a.m., there is a spike of number of actions created. Then you see at 2 p.m. and the 10 a.m., fairly less. Then again, we see at around 5 a.m. and around 9 p.m., there is a spike of cord action being created. If you do the same distribution over a minute, you'll see at one point of time, it's fairly high, it's very high, and other point of time, it's almost zero. Then we have some good numbers, but then like it's zero, then good numbers, something like that. And why does this happen? This happens, as we talked, that there are multiple coordinator jobs running at a different frequency. What happens is that at one point of time, they all collide at the same time. And we'll have an outburst number of cord actions get created. And which single host can't handle that. We have noticed a processing delay, and then customer, they complain the slowness. Going forward, I mean, why do we need downtime? I mean, why can't we just have Oozie server running all the time? At Yahoo, we do one major release per quarter and then minor release every month. And whenever you have to do a release, we have to bring it down. There is no way out. Also, the component dependency. Currently, Oozie are dependent on Yarn, SDFS, Hive, HBase, Peak, HCatalog. And it's tightly coupled. Currently, it's tightly coupled. We are working on that, but currently it's tightly coupled. So if any component get upgraded, Oozie has to get restarted to take those upgrade affected. Configuration change. If we have to make any configuration change in Oozie, or we have to do any fine tuning, currently we have to restart Oozie. We can't do it on fly. Hardware error, those are unavoidable. If any hardware error happens, we need to do hardware switch. And Oozie will go down. There's no way to that. We talked about different category of businesses which uses Oozie, and then we also saw a live example. Those are very critical to Yahoo, and they run over Oozie. So it's very important that, from the customer point of view, that Oozie should be running every time. A delay of around minutes also cause revenue loss to Yahoo. Ops, they are always under pressure to have Oozie server running, mainly for two reasons. One is because of revenue, things get processed by Oozie, and other is the component dependency. If one component goes down, it's like whole cluster going down. Then what's the solution to this? The solution is high availability. And if you define that, like failure of one component is like failure of entire system. And what we should do, we should remove the single point of failure. And the requirement should be like, for user, it should not matter. For them, they should be able to use the same way they're using in non-HA environment. There should not be change in API or user's parent. This is a simple diagram of representing Oozie in HA. There is a user which submit. There is a user which submits request which goes by the load balancer, which goes to one of the Oozie server. And then Oozie server also talks over to other Oozie servers, and we'll see why they need to talk. We also have we have Oracle database, which are also in HA rec system. We use Zookeeper, which also in Quorum, and Hadoop cluster. So if we talk in terms of database, Oozie store all state information, like submitted workflow definition, everything into the Oracle database. Our Oracle database are HA. It has a 2-rack, which uses hot and warm setting. We use Zookeeper for coordinator, mainly creating logs, distributed ID, those kind of things. In terms of access to the user and client program, they need a single address. They don't have to talk to the multiple addresses. They need only one single address to access web UI, REST, and Java API. For that purpose, you use BIP as a user-facing URL, and they go via BIP. For security, we use Kerberos and some of our internal security mechanism to communicate among components. We'll see that. So when users submit a request, it goes by a load balancer. They use HTTPS. They can use Kerberos or our internal cookie-based authorization. But when Oozie servers talk to other Oozie servers, they only use Kerberos. When they talk to a Hadoop cluster, they use Kerberos. When they talk to Zookeeper, they use Kerberos. To talk to Oracle database, they use password-based authentication. So moving forward toward the technical challenges. One challenges we had is the log streaming. Currently, each server were maintaining their own log on the local file system. In HA, a given job can execute in any server. And sometimes it happens that the one part of job get executed in one server, and other part of job get executed in the other server. From the user point of view, they need to see logs in a sequential format rather than seeing the server log for server 1 and server 2. So this is the architecture of log streaming. So user submit a request to a Oozie server by a BIP using correct authentication model. The server The server calls zookeeper to get the list of servers in HA, and then that particular server calls other servers to fetch the log from each server. And once he get the log from other servers, use the log timestamp to merge them and then send it to user. For this purpose, it's very important that all the servers are on the same, they have the same clock setting. One caveat currently is that the log are stored on the local file system, and if any server goes down, a user can't see the log. And we are working on this. This is one of our future tasks. The other challenges we had is mainly edge care integration. We talked about the coordinator, which runs at every frequency and create a correction, which looks for input data set in SDFS or wherever. And if data is available, it starts a workflow, which can run on that data set. There are two ways to do that. One is mainly pooling, and other is notification. For notification, we use HCAT. Oozie, what Oozie does is that when it starts a correction, it registers to HCAT for that particular data set. And when the data set is available, HCAT notifies via the JMS. And then once we receive the notification, we start workflow immediately. We talked about the scale. We talked that at one point of time, we'll have a tremendous number of corrections created. So what we do is that we maintain in-memory list of data set with need notification. This is done for the performance basis so that we don't have to go and query DB every time. The notification can come to only one server. Once the notification comes to one server, Oozie need to invalidate cache in other servers so that other server also doesn't start the same job. And this is done by having a periodic task on each server, which goes and check the status of data set and the job status. And if job is not in waiting state, that means it's moved from the waiting state by other server, and it goes and remove that setting from the in memory. So this is how it works. So there is server 1 and then server 2. Server 2 receives a notification. Server 1 periodically checks, and then he figures out that job status got changed, and then he removes the setting, the entry from the internal memory. We had other challenges, so mainly in terms of ID. So every time we create a job ID, we increment a number, and then always the job IDs are in incremental order. The one we created before will have a lesser number. The one created after will have a higher number. This was perfectly fine in a non-HA environment where one single host was running, and we had a very simple mechanism where we use atomic long and then keep on incrementing that. But in HA, the things got complicated because the job submission in one server can be more, and the job submission on other server can be less. So there can be a difference of IDs being created. For this purpose, we use Apache Curator, which have their inbuilt mechanism of having a distributed atomic long. That was okay, but then we noticed that it doesn't work with a scale. And then, again, I will refer that we talked about that a given particular time there will be a lot of job submission, and then Apache Curator distributed atomic long doesn't work in that case. So it works in most of the cases, but doesn't work in that case. So if we see any error, we fall back to the local counter, and there is a chance that we have a sequence not getting generated properly, but that happens rare. So we didn't work much on that. We keep as it is. The other problem was the zookeeper failure. We use zookeeper for the locking mechanism. Whenever one server start running a job, it creates a lock in zookeeper so that other server doesn't start the same job. And if zookeeper goes down, it will be chaos and Oozie, and each server will start running their own jobs. For this purpose, what I have done is that if zookeeper goes down, we automatically shut down Oozie so that ops can get notification and then they do whatever they want to do. Sometime back, we worked on SareLib. This is one of a very good case. We noticed that a lot of people submit their Pig job, Hive job, HBase job. Earlier, they used to bring their own library, and there was a conflict. Every time we change the Pig version, we change the Hive version, they have to go and update their libraries. We introduced something called SareLib, where Oozie maintained a list of jars needed for Pig, for Hive, HBase, and they say that we need to use Pig jars. That's it. And then internally, we put into HDFS and unload it from there. Every time we have to upgrade a new Pig version or Hive version, what we do is that we just go and upgrade the SareLib. User doesn't have to know what jars they're using. So that was very useful and very easy for the users. With HA, things get complicated because each server used to maintain their own list of jars, SareLib jars, and if you upgrade, we need to make sure that those jars are updated in all Oozie server. So what we do is that when you so for this so the way it get updated that when it's normally done by the ops, they go and update the SareLib jars in the SDFS. They make a call to Oozie to go and refresh the SareLib jars. And what we do is that if the request comes to one server, the server goes and updates their SareLib jars, and it redirects to all other servers to update their SareLib jar. There are some more challenges in terms of SLA support. So Oozie also has a SLA support where you can specify some of the SLA attribute to the job, saying that this job should start in 5 minutes, should end in 10 minutes, should run at the maximum duration of, say, 8 minutes or 9 minutes. So you can specify those are the components in the job itself. Again, we used to do this in memory. A lot of things we used to do it in memory. And we wanted to avoid DB calls because we know that at one point of time, there was a scaling issue with the DB calls. We make so many. And same as the HCAT integration also has a problem that if one job has executed the SLA information for particular state, how do you make sure that the other server doesn't do the same thing? So for this purpose, what we do is that every time we try to process SLA information, we go and check the SLA status across the DB. And if already processed, we remove it from database. We talked about the distributed log. We use Apache curated distributed logs. And then one good property of Apache curated distributed logs are they are reintrant. In Oozie, everything is a command. So what we do is that, and one command will invoke a multiple commands within the same thread. And this is very important that those are reintrant, because if one thread is executing something and it calls a different command, that command should also get executed. It should not wait for the log. So those were some of the challenges we faced. And we'll talk about our experiences. Oozie HA is running for more than 7 months, and it is stable. We had some glitch, but it's fairly stable, and we never had a major problem. We had few issues where if you want to move our whole Zookeeper cluster to a beta server, in those cases we noticed that the Oozie goes down, because we added a functionality in Oozie itself that if Zookeeper is down, it will bring it, the Oozie server will go down. So that one glitch we had. Since we do a rolling upgrade, and then one server get upgraded first, and then other server get upgraded second, there is a time that each server goes out of sync, because during upgrade, if one server is upgraded, other server is not upgraded, they will have a different setting. Same as the SareLib. At one point of time, one server will, that happens for the short duration, but it will happen that one server is using a different set of jars for job submission, where the other server is using different set of jars. Benefits, yeah. In terms of benefits, there was zero downtime for all critical applications which runs on Oozie. There was zero downtime during maintenance upgrade, the configuration upgrade. And we also talked about the scale and we saw that processing delay. So we did notice that in HA, Oozie HA. To collect some of the performance metrics, what we did is that we took HA and non-HA environment, and we started submitting jobs, and we started increasing the number per minute. When you try to submit 500 jobs per minute, HA and non-HA, when you talk of HA, it's a two-node cluster. 500 job submission per minute was fairly okay for both of the environment. 1,000 also no problem. But with 1,200, we noticed that HA was 100% job submission. Non-HA, we noticed that around 99.7. With 1,500, HA was fine, again 100%. Non-HA was, there was some rejection, so it was around 98% or 97%. With 1,800, HA was perfectly fine, but non-HA, we noticed it's around 89%. But then again, once you move over 2,000, we notice that even non-HA, even HA can't handle that. Non-HA was even worse than that. Same as this number. Yeah, this is in comparison to 2-node. If you can increase 3-node, we'll get better number. But this doesn't scale that way, because we also have a dependency with database, SDFS, a zookeeper. So it doesn't always mean that you keep on adding numbers and you'll give a fairly improving results. So no, it doesn't work that way because of the dependencies. Some of the future work which we're going to work on. So one thing is since Oozie process a lot of critical revenue thing, we want to do a faster recover. Currently, on each Oozie server, we had a periodic task which keeps on checking job, and if any job is not more, it's runnable, it has to run. I mean, if it's not being run for more than 10 minutes, what we do is that we take it and execute that. In future, what we want to do is that if one server goes down, and if that is processing some job, we want the other server to immediately take over those jobs and start executing. We talked about some of the limitation of log streaming. We want to move the logs to the SDFS, so that even though the server goes down, the logs will be available and the other server can read it. We want to acknowledge a few people. Without them, this would not have been possible. Melly Robert, who works for Cloudera, he was the one who initially started working on the Oozie HA. Olga, she's a part of a Hadoop team at Yahoo. She's a senior director. Rohini, she's a lead for Oozie and Pig at Yahoo. Michelle, she's Oozie QA. Jacob is a data pipeline engineer, and he helped us to explain the data pipeline use case. Sumit helps us on reviewing our PPT content. Thank you. That's it. Any question? Yeah.
So are you going to release this to be publicly available?
Oozie HA is publicly available, yes. It's already released. Version 4.1.0 is Oozie HA.
How about jobs that are not just started every time they're needed, but can run really long time with just update and so on? Do you have some solutions for this?
Come again, I didn't understand that. So,
If it's not just one-time submitted job from user, but really long stories, do you have some better solution with Oozie for that?
so you're saying that, are you saying that the periodic execution of jobs?
If you have some longer than just short time job.
We have a longer jobs. There are some jobs which, mainly the big jobs, which runs more than 4 or 5 days, and there's no problem with that, because it's mainly Hadoop job. So what Oozie does is that it sees that I have to submit a big job, submits to Hadoop, which runs for 3 or 4 days.
If it's permanent servers doing requests and so on and so forth. it's not just job, but something like service, like jobs that receives external requests, not just processing final amount of information. Do you have solution for this with Oozie? Upgrade, especially zero time upgrade.
I'm sure that I have understand that properly. But we don't do any processing on Oozie server itself. Any job processing happens on, so any job we submit to Hadoop, we submit two jobs. One is a launcher job. Like if we have to submit a pig job, we submit a launcher job, which parses pig script and submit all the child jobs. Oozie doesn't do that. Oozie uses Hadoop to do that. So we have a very minimal processing. At Oozie, we just parse the workflow XML. Use a launcher job to submit actual job.
When we have been using Oozie and together with many other parts of the Hadoop stack, we have had issues when running in security mode. Usually, all parts work well with security. Kerberos enable security, but when playing together, often with Oozie, they tend to not agree on whether or not something is authenticated or not. Have you experienced issues such as this? Because if you're using it for, what was it, 30+%?
Yeah, no, we never had any issue with the security. It works perfectly fine. If you set up your key tab, everything perfectly okay, then it works fine. We use Kerberos to talk almost every component. Like when you talk to Hive, we talk to HCAT, we have to get delegation token for each and everything is on Kerberos. We talked about the user interface where you use Kerberos plus some of our internal cookie-based mechanism. But within the Oozie, talking among Oozie or talking with other components, it's all Kerberos, and we never had an issue with that.
Hi. When you mentioned about log streaming, did you mention the job history or local server logs?
This is a Oozie server log, not that.
Ah, okay. Okay.
Not that. So sometimes, like when you submit a workflow, there are some issue with the workflow. Your workflow definitions are not correct and something like that. So we give it to users so that they can troubleshoot that. So it's basically Oozie logs, not the job logs.
And currently you're just keeping it on the server?
We keep in the server, yes.
Okay.
Yeah, we plan to work on that, where we'll move it to SDFS, and even if that particular server die, which executed the job, we still have the log available.
Okay, thanks.
Thank you.